Medical imaging, the visualization of body parts, tissues, or organs for use in clinical diagnosis, treatments, and disease monitoring. MRI, CT scan, X-ray, ultrasound, and diffuse optical imaging are some main examples of medical imaging techniques. But wait a minute, you are probably thinking, I know all of those, but what is diffuse optical imaging? Optical techniques will making an impact in the absorption of oxy and deoxyhemoglobin to assess blood oxygenation. The biomedical optics found this useful information by the examination of the absorption of tissue, provided that the effects of scattering of light were minimized. Hence, near-infrared spectroscopy is made at which the absorption and scattering are low. And IRS is a smaller band of infrared because the main absorption is the oxy and deoxyhemoglobin and water. The wavelength usually used is between 780 to 850 nanometer. Oxy and deoxyhemoglobin absorb different wavelengths of light differently, so their concentrations can be varied with measurement using multiple wavelengths of light. When an IRS travels through tissue, it does not travel in a straight line. Instead, each photon moves in a random direction from one scattering to the next. The light field created by the photon is called diffuse. Diffuse optical imaging is a natural extension of an IRS and has two main clinical applications, which is brain imaging and the imaging of breast cancer. It is made out of fiber and it monitors changes in concentration of oxy and deoxyhemoglobin. A typical DOI device has sources to emit light, detectors to absorb and respond to light, a computer to analyze and view results, and a machine to control sources and detectors. It is unlikely that DOI will replace any of the established imaging methods, but it has its advantages such as being cheap, non-invasive, and portable.